This really should have been the first video, but it's here now and it's going to cover a lot, so make sure to rewatch until you fully understand all of the concepts. So what is trigonometry? Trig, as it's often shortened to, is the study of right triangles when you know the lengths of the sides or the measure of the angles. To accomplish this, we take an arbitrary right-angled triangle, drawn here, and pick either the two non-right angles and label the sides as such. The largest side is always the hypotenuse. The side opposite to the angle is the opposite side, and the side that touches the angle is the adjacent side. Going further, the angle that we reference will usually be named theta, the Greek letter. Greek letters are commonly used to reference angles. Now, it is true in geometry that if I scale this triangle, that is to multiply all of the lengths by the same number, the angles do not change. And since all the sides are multiplied by the same amount, their ratios do not change. So clearly, the ratios of these sides in a triangle are tied to the specific angle. There are three ratios we can compare: the opposite to the hypotenuse, the adjacent to the hypotenuse, and the opposite side to the adjacent. These ratios are called the sine of the angle, the cosine, and the tangent, respectively. As a short form, people refer to this as SOHCAHTOA. To remember that sine handles opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. With this right-angled triangle, we also see that 90 minus the angle flips sine with cosine, because that flips which angle we are dealing with, changing the opposite and the adjacent sides with each other. Here's an example. This right triangle has sides 4, 3, and 5. The sine of this angle here is the 3 over the 5. The cosine is the 4/5, and the tangent is 3/4. To find the angle between the 4 and the 5, we use the inverse sine on 3/5, the ratio, to obtain an angle of roughly 37 degrees. Additionally, if you had this triangle, we could find the opposite side by multiplying the hypotenuse with a measure of 10 by the sine of the angle, which a calculator tells us is 0.5, and obtain the opposite measure of 5. In addition to those three ratios, we have their reciprocals, where the cosecant is the flipped version of the sine, the secant is the flipped version of cosine, and the cotangent is the flipped version of tangent. Let's look at this very special circumstance. What if the hypotenuse is 1, where everything is scaled according to this length? Now, dividing by the hypotenuse does nothing, so we can see that sine is the same as the height of the triangle, and cosine is the width of the triangle. In fact, if we lock this point in place on a triangle, changing the angle associated with that point, it outlines a circle of length 1. This is the well-known unit circle, where if we pick any point on the circle, a right triangle can be made by drawing a line straight down to the x-axis. As established before, now the height or the y-coordinate is the sine of the angle made by hypotenuse, and the x-axis, the width, or the x-coordinate, is the cosine of the triangle. Look at these 4 points. At 1, 0, the cosine is at its max value, and at minus 1, 0, it is at its minimum value. This is also true for sine, for 0, 1 being the max, and 0, minus 1 being the minimum. This means that cosine is 0 at 90 degrees, all the way at 270 degrees, and sine is 0 at 0 degrees and 180 degrees. And yes, we've expanded our trig to include all angles up to 360 degrees, according to how much the hypotenuse has rotated away from the x-axis. Positive angles can be found by using the related acute angle. The related acute angle can be found using one of these formulas that I have up on screen for each of the 4 quadrants. Always remembering that you can use your guidelines at 180 degrees and 360 degrees to fill out what the related acute angle should be. The angle that we always talk about in trigonometry is known as the principal angle, and that's always going to be how much we've rotated counterclockwise away from the x-axis, going positive. To find trig ratios of angles greater than 90 degrees, we're going to use these acute related angles. So an example would be if the sine of 30 is 0.5, then the sine of 330 is minus 0.5, since the acute related angle is 30 degrees to get us to fill up the full 360 degrees. And now the sine of the angle is actually negative here because the height is negative. Sines are always negative when we're talking below the x-axis, and cosine is always negative when we're talking to the left of the axis. And tangent is going to be negative whenever only one of them is a negative. So the top left quadrant and the bottom right quadrant. To take away from this unit circle as well is that we can now use the Pythagorean identity between sine and cosine, where the sum of their squares is always equal to 1, since 1 is the length of the hypotenuse made at any angle on this circle. Another identity, which is a term for something that's always true, is that the tangent of an angle is equal to the sine over the cosine. And you can see this as sine is the opposite length and cosine is the adjacent length. And changing the hypotenuse only changes the size and not the ratios of the triangle. We will use identities to prove compound angle formulas in another video. Lastly, for this video, let's talk about what's known as radians. If we imagine rotating around the unit circle, what would be the angular speed to achieve a unit velocity around the circle, where angular speed is the number of degrees you change in a second, and velocity is how much distance you cover in a unit second? Well, if we went 1 degree per second with a circle of radius 1 meter, then we would rotate the full circle in 360 seconds, a distance of 2 pi or 6.28 meters. This is obviously too slow to be the unit 1 meters per second. To rotate a speed of 1 meters per second, we would need to rotate the full circle in 2 pi seconds. Let's call this angular speed 1 radian per second, where radian is the measure of the angle equal to the length of the circle traveled. To find the value of 1 radian, we know that pi, or half the circle's distance, is equal to 180 degrees. So 1 radian is equal to 180 over pi degrees, or 57.3 degrees. To convert between radians and degrees, use these on-screen formulas, always remembering that 180 degrees is the same as pi radians. With this new measure of an angle, we have a weapon to naturally graph the sine and cosine of an angle without having to stretch things out on the x-axis all the way up to 360 degrees. And you'll notice that when we use trigonometry in regards to calculus, you cannot use degrees and you must use radians, because that's what happens when something travels at a unit velocity around the circle. After all that content, I hope you have a basic understanding of the basic ratios, identities, and the new type of angle, radians. Until next time, keep on learning.